So we are going to talk about zeros and multiplicity today. It should be a pretty easy lesson. All right. A function f has at most n number of real zeros, where n is the degree of the polynomial. So if you have a polynomial of degree 5, at most it's going to have 5 zeros. It's kind of a way that you can check yourself. Now let's talk about the word zero for a second. What is a zero?
That circle looking thing?
Yes. X-intercepts. What else is a zero? Solutions. And one more word. Starts with an R. Root. All right, so roots, solutions, x-intercepts, zeros, all of those are interchangeable and they all mean the same thing. So when I say that there is n number of zeros, it means it's going to cross the x-axis n number of times. Now what we're going to see today is repeated roots. So roots that are going to happen more than once. And repeated roots we will label with something called multiplicity. All right, so for example, down here, if I have this expression here, x plus 2 cubed. This cubed means that x plus 2 is happening 3 times. 1, 2, 3. Is the answer going to change, though, for these 3 times? No, it's still going to be negative 2. So what we say is we say it has a 0 of negative 2 with a multiplicity of 3. So if you see that word multiplicity, that means that 0 is just happening more than once. It's got to do with the exponent. All right, so the multiplicity is the exponent of the factor. Not what's with x, it's the exponent of the factor. So in my example that I got going on right here, this 3 is coming from that 3 right there. The exponent on the outside of the factor. All right, so you're like, all right, that's great. Why do we care about multiplicity? Because it's going to help us graph. So if you have an even multiplicity, then the graph is going to bounce off the x-axis at whatever that 0 number is.
Oh, are you lying?
I don't know.
Is it bounceativity?
No.
Are you lying?
All right, if it is odd, it's going to cross at wherever that 0 is. All right, so I know things are going to get confusing because we talk about even and odd stuff in a lot of different scenarios. So we talk about even and odd symmetry. We talk about the even and odd degree. That's going to help you determine end behavior. And now we're going to talk about even and odd multiplicity. That's going to determine whether stuff crosses or bounces. So I know it can get a little confusing all up in your brains, but try to keep it straight. All right, so I have a graph here as a visual of what happens bouncing versus crossing. So right here, you can see I go down and I touch the x-axis and I bounce off it like a trampoline. All right, so I don't go through it. I literally hit it, bounce off it. This one here goes through it, and so that would be an odd multiplicity. If you cross through it, it's odd.
Can you bounce?
No. All right, so on 18, find the zeros of x plus 2 cubed times x minus 1 squared. And then I did put a graph of that function over here to the right, so we can just kind of start comparing my answers to my graph. So you can see that what we're finding is truly happening. All right, let's find the zeros first. So I'm going to take my factor x plus 2, and I'm going to equal it to 0. And when I solve this, I get x equals what?
X equals negative 2.
Negative 2. All right, what is the multiplicity of x equals negative 2?
3.
3, because of that cubed right there. So my multiplicity is 3.
So do we have to write out, like, we always have to write the
If it asks for it, yes. But if it doesn't ask for it, no. But I'm going to write it just because that's what these notes are over. Now, because my multiplicity is 3, is that going to bounce or cross on my graph?
It's going to cross.
It's going to cross. So if you look over here at your graph at -2, you can see that we are going crossing through it. It crosses it kind of at a squiggle, but it still crosses my graph. Okay, so let's talk about the other 0, so the x minus 1. So I would take x minus 1, equal that to 0. So where would I hit the x-axis at? 1. What would my multiplicity be? 2. And so that multiplicity there is coming from the 2 right there. Are you going to bounce or cross? Bounce. And so you can kind of see on your graph right here at 2, or I'm sorry, not at 2, at 1. We go down and hit it and bounce off it. So it doesn't go through it. It bounces off the graph. All right. So let's look at 19. Right here, we're just finding the zeros and we're describing what it does at the x-intercept. What are you doing?
I'm skipping.
Skipping. Go to class.
Wait, no. I'm supposed to be taking pictures, but like.
Oh, go take a picture.
Well, it's not till 10:30, but I told her 10.
You cannot come in here.
I have to take a test in here, right?
No.
Oh, Miss Stahl.
No, you can't skip. You'll get me in trouble. Go in Mr. Stahl's.
Okay.
He's braver than me. All right. It is on the recording. I just realized that. It's okay, though. Because I said no. I was strong. But I did throw my husband under the bus. All right. On this one. A lot of you can probably start doing stuff in your head, so you don't always have to write down like x minus 2 equals 0. You can do it in your head and just tell me where are you going to cross the x-axis at?
2.
At 2. What would your multiplicity be?
3.
3. And are you going to bounce or cross? Cross. All right, now this next one, 2x plus 8. Can you do that in your head? Where would you hit the x-axis?
-4.
-4. Good. What's the multiplicity?
1.
1. Are you going to bounce across?
Cross.
Cross. Very good.
What did you
If what are going to be the same thing?
That x plus 1. I'm turning to x minus 1.
Oh.
Let's see if 3.
Yes, it would. Mm-hmm.
What?
Sorry, he's just, bear with me. Okay, where is the next one going to be at?
X minus 4.
-4. So do you see how it happens again? So just looking at this one, where would your multiplicity be? 2. But because it actually is happening, those are the same number, right? We can combine that and say that x equals -4. My multiplicity would be 3 because it's happening 3 times. 2 there, 1 there. And so altogether, it is still going to cross. Does that make sense? Because it wouldn't make sense to plot -4 and cross through it and then plot -4 again and bounce through it. That wouldn't make any sense. So what you would do is you would add them because it's just the multiplicity is just how many times it's occurring. So since it occurs once here and twice here, it's occurring a total of 3 times, and 3 is odd, so you would cross. All right, next one. Find the zeros and describe what the function does at the x-intercept. So same thing, finding the zeros, telling me what it does. Where would that 0 be at?
0.
At 0. And are you going to bounce or what's the multiplicity? 1. And so are you going to bounce or cross? Cross. All right, this guy here. The cubed is on the inside. So when I'm talking about the multiplicity, it's still going to be 1. Because the multiplicity deals with the exponent outside of the factor, not the cubed on the inside. Does that make sense? Okay, so I don't care about that cubed on the inside for the multiplicity. I just care about how many times is that factor occurring. It's occurring once. Now to solve, we are going to take this guy and equal it to 0. All right, so this one we might need to write out instead of doing it in our head. So what would you do first? Subtract the 1. And then? Cube root. Can you cube root -1? Yes, what is it? -1. So my 0 is x equals -1. What is the multiplicity? 1. And so you are going to cross. All right, so I have 2 zeros on this one. The 0 from the -2x, that has an exponent of a 1. It's going to happen one time it crosses. Now this one, this factor happens one time. So when I set this guy equal to 0 and solve for it, that answer is still only happening once. So it has a multiplicity of 1, which means you would cross. All right. So what we're going to do is we're going to sketch these polynomials. So we're going to be able to be a little bit more accurate with my sketching. All right, so the first thing I want to do is I want to find the zeros in the multiplicity. Then I'm going to find the degree and the leading coefficient to determine what the end behavior is doing. And then I'm going to sketch the graph. Okay. On this first guy, what would be that 0 from the x on the outside?
0.
X equals 0. What's the multiplicity? 1. Are you going to bounce or cross? Cross. All right, what about the x minus 3? X equals 3. What's the multiplicity?
2.
Bounce or cross? Bounce. And then x plus 5, what's the multiplicity? -5. Bounce or cross? Oh, sorry, what's 1 multiplicity and then cross, yep. All right, sweet. So I got all my bouncing and my crossing. So I can come over here on my graph and I can plot 0. I can plot 3 and I can plot -5. Now, I have to figure out my end behavior before I do all my bouncing and my crossing because I don't know which way it's going to bounce or which way it's going to cross. So that's why I need the degree and the leading coefficient. Now, yesterday when we found our degree, we had polynomials in standard form. So it was like x cubed plus x squared plus x, blah, 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 in descending order. Well, this guy is factored. And so I am going to have to multiply it all out. Now, do you want to have to multiply and FOIL everything out? No. And in fact, you don't have to. Because when you're talking about the degree, I only care about the biggest exponent. So I'm only caring about the biggest stuff. So I care about the x, I care about the x squared, and I care about this x. What I don't care about is this -3 and this +5 because I know that that's going to give me the smaller terms. So I just care about all of those leading terms in each part of your factors. So when you take x times x squared times x, when you take all of these leading terms and you multiply them together, that will give you the leading term of your polynomial. Does that make sense? Okay, so what's x times x squared times x? X to the 4th. So what would your degree be? 4. What would your leading coefficient be? 1. All right, and so then for your end behavior, the limit as x approaches infinity of f of x, what would the right side be doing?
Even. Go up.
It go up. And what would the left side be doing?
Down. Oh wait, it's even up.
Also up, yep. So positive leading coefficient, right side's going up. Even degree, they're going to be the same. All right, so over here on my graph, I know that my end behavior is going up. So I know from this 0, we're going to go up, and then from this 0, we're going to go up. So the ends of my graph are going up. Now I have to determine whether I'm bouncing or crossing. So at -5, am I going to go through or am I going to bounce off it?
Through.
I'm going to go through. Because at -5, it tells me I'm going to cross. Now, it's a sketch, so we don't know totally how far down this graph goes. All right, But we do know we have to turn it and come hit this next point right here. So we're going to turn it and hit this red point. And at 0, we are going to cross again. So we're going to cross again at 0, and then we're going to turn once again. We don't know how high it goes up, but we do know it's got to turn and it's got to come meet this orange point. And at the orange point, should you be bouncing or crossing? Bouncing, which makes sense because that is what's happening. It should match up with your end behavior. All right, so you're bouncing and you're crossing and all of that good stuff. It should all match up with your end behavior. Otherwise, you did something wrong.
So to find the degree, we just combine all the x's.
Mm-hmm.
Okay.
So,
Unless it's like when there's parentheses, we would combine all the x's.
Yes.
When there's not, we just look at,
yep.
okay.
All right, so let's do the next one. For this next one, if I take this first factor on the outside, where would that 0 be?
0.
At 0, what's the multiplicity?
2.
2, bounce across?
Bounce.
Bounce. All right, what about the next 0? Where is that guy going to be at?
-2.
-2, what's the multiplicity?
3.
Bounce across?
Cross.
Cross, perfect. And then the next 0, where is x minus 4 going to be at?
4.
4, what's the multiplicity?
1.
Bounce across?
Cross.
Cross.
Cross. Cross.
All right, so I'm going to come over here on my graph, and I'm going to plot 0. I'm going to plot -2. And I'm going to plot 4. Now, I got to figure out the degree.
Yeah.
So I'm going to come to my polynomial. Since it is not multiplied out, I got to imagine what would happen if it gets multiplied out. So I'm going to multiply all of the front things. All right, the biggest terms and all the stuff. So I'm ignoring the +2 and the -4. So essentially what I'm going to be multiplying together is -2x squared times x cubed times x. Yep. So what would your degree be?
6.
What would your leading coefficient be?
2.
Okay, so then for my end behavior, what is the limit as x approaches positive infinity? And what is the limit as x approaches negative infinity? All right, good. So it's even. They're both going to go in the same directions. Your leading coefficient is negative. They're both going down. So when I go to my graph here, I know that end behavior goes down, end behavior goes down. All right, at -2, the orange dot, am I going to cross or am I going to bounce?
You're going to cross.
Cross, and then I'm going to go down to the red dot here at 0. What's happening at 0? I'm bouncing, so I'm going to hit it and I'm going to bounce off. And then I should meet up with the green dot, which it should be crossing. Yep.
So now we don't need to have 5 bounces. It just could have 5 bounces.
Mm-hmm. So this one only has 3. But if you graph anything more than 5, that's wrong. Or if you're trying to match it up, that's a way that you could match up. Alrighty. Last.
Easier.
This is easier? Good.
Well, now we're doing Punnett squares.
Squares. All right. This last one, I just kind of give you less information. All right, I'm telling you that you have a 0 at -3 with a multiplicity of 2. And you have a 0 of 4 with a multiplicity of 3. And then I'm also telling you that a is greater than 0.
No clue with that. Yeah.
All right, so the a is just your leading coefficient. So this is telling me my leading coefficient is positive because it's greater than 0. So that's that last little part there with the a. That's just talking about your leading coefficient. I also am going to need my degree, right? Because I got to figure out my end behavior. So the degree is the highest exponent. What else is dealing with the exponent?
The multiplicity.
The multiplicity. And so, yes, your degree would be 5 because you would just add up all the multiplicities.
Wait till we get
All right, so I'm going to plot my zeros. So I've got -3, 1, 2, 3. And I'm going to plot 4. 1, 2, 3, 4. For your end behavior. All right, I'm not going to write it in limit notation. I'm just going to draw some arrows. Since my leading coefficient is positive, what's the right side doing? Going up. And since my degree is 5,
Go down.
yep. So it's odd, so they're going to go in opposite directions. Now I just have to figure out my bouncing and my crossing. So at -3, am I going to bounce or am I going to cross? Bounce, because the multiplicity is 2. So I'm going to bounce there, and then I'm going to hit at 4, and then what should you be doing at 4? Crossing, which makes sense because that matches up with your end behavior.
Wait. Did you know to bounce down?
Because you can't cross through it to go positive.
Like, how did I know to go like that?
Christmas.
Because you can't cross through it because the multiplicity is even, so you have to bounce down. Mm-hmm. All right, same thing over here. So the a less than 0, that just tells me about my leading coefficient. So my leading coefficient is negative. And then it gives me information about my 0. So I have 1 at -1 with a multiplicity of 2 and x equals 3 with a multiplicity of 2. So what would my degree be? 4. And so let's plot my zeros. I've got 1 at -1 and 1, 2, 3. One guy at 3. Okay, so for my end behavior, your leading coefficient is negative. What's the right side going to do?
Negative infinity.
And what's the left side going to do?
Negative infinity.
Yes. So my arrows are going to go downward. All right, my multiplicity is 2. Are they going to bounce or cross? Bounce. They're both going to bounce. So we are going to hit this first 0, bounce off it, turn around somewhere. We don't totally know where. It doesn't matter. But you got to turn around to hit your next 0, and then that one bounces off it too. So it kind of looks like M. All right, feel good?
Yeah.
That's it. So let's look at your homework. All right, the first two are very similar to what we did on the notes for today. You've got your factored version, you're doing degree, leading coefficient, all that jazz. There are 2 of them on your homework here that are not factored for you. So you would have to go and factor them.
We
So-
find the leading coefficient first.
Yes. So the leading coefficient, the degree, you would find from this original guy. But to get your zeros, you would have to factor. Does that make sense? So then this one would be a trinomial. And then the other one that you're going to have to factor is going to be number 6. How would you factor number 6?
The grouping.
The grouping. Yep. However I want, yes. And then you're going to do degree, leading coefficient, multiplicity, whether you cross or bounce. If you want to put C and B instead of actually writing the word, I'm fine with that. And then you will sketch the graph over there on the right. Good? Yay.